Hey everyone! Every single thing you do online, everything from just scrolling through your feed to buying something, it's all powered by this one fundamental process. It's basically the heartbeat of the entire internet. And today, we're going to put our finger right on that pulse and trace the journey of a single click. So picture this, right? You've been searching, you found the perfect thing online, and you hit that Buy Now button. In that tiny little split second, that moment between your click and when you see that confirmation screen, an absolutely incredible, super high-speed journey is taking place. So what is actually happening in that little moment? Well, that one little click, it kicks off this, epic journey. Seriously, your request is zipping from your device all the way across the internet to some server in the cloud, and then it gets a response all the way back, and this all happens in the blink of an eye. It's wild. Let's break down that trip. Okay, so this whole trip happens in 6 main stages. First up, your browser needs to find the server's address, right? So it does what's called a DNS lookup. Just think of it like looking someone up in the internet's giant phone book. Once it has the address, step 2 is the handshake. This is where it sets up a secure connection using TCP and TLS, basically making sure no one can listen in. Then, with that secure line open, it sends the actual message, the HTTP request. That's the part that says, hey, I want to buy this thing. The server gets that message, does its thing, processes your order, and then sends a reply back. That's the HTTP response. And finally, the big reveal, your browser gets that response, puts it all together, and shows you that beautiful order-confirmed page. And that's the whole cycle. All right, so the server gets your message. It knows exactly what you want. But now it's at a crossroads. It has to make a really fundamental choice about how it's going to handle the work you just gave it. And that choice really boils down to this. Should I do all this work right now and make you wait for the answer? Or can some of this be done later, in the background? This simple question is the core difference between 2 super powerful communication models, synchronous and asynchronous. Let's start with synchronous. The easiest way to think about this is like a phone call, right? You dial the number, you hold the phone to your ear, and you have to wait on the line until someone picks up and gives you an answer. That conversation is happening in real time, and you're kind of stuck. You can't really do anything else until it's over. It's a direct, one-to-one, blocking kind of interaction. Now, asynchronous communication, that's the complete opposite. It's way more like sending a text message. You type out your message, you hit send, and then you're free. You can put your phone down, go make a coffee, do whatever you want. All the work, the other person reading it and replying, that all happens in the background. You just get a little notification when the response is ready. It's non-blocking, and the 2 sides are decoupled. They don't have to be connected at the same time. So, there you have it, the phone call model versus the text message model. And look, neither one is just flat out better than the other. They're just different tools for different jobs. The real key to building amazing, efficient systems is knowing exactly when to use which one. Okay, at a super high level, it really just boils down to this. Synchronous, you get an immediate response, but the client and server are really tightly connected. We call that tightly coupled. Asynchronous, the response is delayed, but it allows all the different parts of the system to be loosely coupled. They don't have to be available at the exact same time to talk to each other. Now, let's really dig into the details and break this down even more. This table here really lays out all the trade-offs perfectly. You see, synchronous is pretty simple to get started with, but its scalability is limited. And think about it. If one part of that phone call drops, the whole conversation is over. That's what we mean by low fault tolerance. Asynchronous, on the other hand, it's a bit more complex to set up, but it is highly scalable and way more resilient. And why is that? Well, because if a service is down when that text message arrives, the system doesn't just fail. It can hold on to that message, maybe in a queue, and just try sending it again later. It makes sure the work eventually gets done, no matter what. So when do you absolutely need to make that phone call? Well, for anything that demands an immediate answer. Think about logging into a website. You need to know right now if your password was correct, don't you? Or when you submit a payment, you want that instant confirmation that it went through. These are just perfect classic examples of when you'd use synchronous communication. And what about the text message? When is that a better choice? Well, pretty much for any task that can just happen in the background without forcing the user to sit there and wait. Things like sending a confirmation email, logging analytics data, or processing a really big, complex order. For all of these, scalability and making sure it doesn't fail are way more important than getting an instant response. But here's the thing. The most powerful modern systems, they don't just pick one and stick with it. Nope, they use both very strategically.
Let's actually look at a blueprint for a modern e-commerce site. This will show you exactly how it all works in the real world.
Okay, so back to our example. You click Buy Now. Instantly, your browser makes a synchronous phone call to the server. The server does a quick check, validates your request, and immediately responds with something like, "Got it, your order has been received." The crucial part here is that you get immediate feedback. You know your click worked. You're not left wondering, did that go through?
But here's the magic. While you're looking at that nice confirmation screen, the system is already busy firing off a bunch of asynchronous text messages in the background. One text goes to the payment service to actually process the charge. Another goes to the notification service to send you that confirmation email. And a third goes to the inventory service to update the stock levels. And the best part? You didn't have to wait for any of that. It all happened behind the scenes.
You know, understanding this blend, this mix of phone calls and text messages, it's not just some academic exercise. It is a practical, honest-to-goodness superpower, especially if you're building software or, hey, if you're getting ready for a system design interview.
And this is exactly why it matters so much. In an interview, being able to explain how you'd use a synchronous API for that first user request, but then switch to an asynchronous message queue for all the background work, wow, that shows a really deep understanding of how to build systems that are both fast and reliable. You're not just spitting out definitions, you're showing you know how to design for real-world problems. All right, so let's do a quick recap of our journey today. First, that HTTP request cycle is the absolute foundation, the heartbeat of the web. Second, you've got the phone call model. That's synchronous, which is all about simplicity and getting an immediate answer. Then you have the text message model, asynchronous, which gives you amazing scalability and resilience. And finally, the most important takeaway. The best modern systems use a smart, strategic mix of both. So I want to leave you with a question to chew on. The next time you're designing a system, or even just looking at an app you use every day, ask yourself this: which parts of this are a phone call and which parts are a text message? Which interactions need that instant, real-time connection, and which ones could be handled with that flexible, super resilient background approach? Because finding the right answer to that question, well, that's what great system design is all about. I really hope this helped clear things up for you.